Topic 1, Day 3, Arithmetic Sequences and Series. So a sequence is a list of numbers that follows a pattern. It can be as simple as a list of positive numbers, 1, 2, 3, 4, 5, or more complex, such as 0, 1, 1, 2, 3, 5, 8, so on and so forth. If we talk specifically about arithmetic sequences, we know that they are arithmetic when you can add or subtract a constant value. So for example, if you're always going to add 2, like that is your pattern, then you have an arithmetic sequence. Or if you're going to take away 3, okay? So if we have this sequence, -2, 0, 2, 4, you can see that we're always adding 2. That's the pattern. That's what makes the sequence arithmetic, okay? That constant value, however much we're constantly adding, is called the common difference. And the common difference uses the variable d to denote, okay? There's some notation that's pretty specific and kind of weird the first time you see it. So when we talk about the sequence -2, 0, 2, 4, we know that the very first term, right, is -2. So n equals 1 just indicates for the first term, the value a sub 1 is equal to -2. Right? So this one here just means first term. What is that first term is a sub 1 is equal to -2, right? So then the second term, n is 2, a sub 2 is 0. The third term, n is 3, a sub 3 is 2, so on and so forth. Okay? The subscript just means the little number next to your letter, tells you the number of the term, right? So a sub 1, a sub 2, a sub 3, so on and so forth, right? A sub n, or a sub some number, and u sub n are going to be the same. On IB, you'll most likely see u sub n. In class, you're going to see both. It's kind of one of those European, American. US tends to use a, Europe tends to use u. It's good that you're able to use both. In order to find the common difference, right? We already indicated that we use the letter D to denote the common difference. And we can always find the common difference by subtracting a term from its previous term. So if we're looking at that same example from before, we can look at the second term and subtract it from the first term, right? So 0 minus a -2 equals 2. But you can also do a sub 4 minus a sub 3. Right? And that's going to give us 4 minus 2, which will also equal 2. So any two consecutive values you can subtract, and then you'll get the common difference. Now, a very common question with arithmetic sequences and series is, well, here's a pattern. What is the 20th term? What is the 100th term? Right? And you could write out 0, 2, 4, 6, 8, 10, 12, so on and so forth, until you get to the 100th term. You could. But that is really, really time consuming. So this equation can help us figure out what an nth term is without actually calculating every single value. So here it says a sub n, so that's going to be the nth term. So if we're looking for the 15th term, we would say a of 15, right? Equals a sub 1, the first term, plus how many terms are there, n, minus 1 times your common difference. Another very common type of problem is, what is the sum, right, adding up, what is the sum of the first 20 terms of your arithmetic sequence? Or what is the sum of the first 1,000 terms, right? So instead of adding every single one of those values together, we have this equation. You actually have two, all right? And you can figure out which equation to use depending on what information you already have. So the first one, if you know the number of terms, divide that by 2, and then multiply that by 2 times a sub 1 plus n minus 1 times the common difference. Or if you have the last term, the second equation does tend to be easier, right? So if you know that you're finding the sum of the first 15 terms and the 15th term is equal to some value that you know, then you can just do n minus n over 2 times a sub 1 plus a sub n. Okay, so again, if you see s, we're talking about the sum, right? A sub n is your nth term. So let's start at teacher example number 1. Given this arithmetic sequence, determine the 15th term. So we're looking for the 15th term, right? If we just kept going on until you got to the 15th term, what would that number be? We're going to be looking at the first type of equations, which is going to be your a sub n equals a sub 1 plus n minus 1 times d. Here we see negative 7 is our first term. That means a sub 1 is equal to negative 7. In order to calculate our common difference, we're going to take the second term and subtract it from the first term. So we're going to take negative 9 minus a negative 7. So our common difference here is negative 2. Right, or subtracting 2 from every term. So go from here to here, minus 2. Here to here, minus 2. And then we know that we're finding the 15th term, so what we're solving for is a sub 15. And n, because we're going to be looking for the 15th term, n is 15. Okay? Now we just plug it into our equation. A sub 15 equals our very first term plus n, 15 minus 1, times our common difference, which is negative 2. Be careful to put the negative 2 in parentheses so that we know that we're multiplying and not just subtracting 2. Put this through a calculator or do some mental math, and you'll find that a sub 15 equals negative 35. Try student example number 1 on your own. Now our teacher example number 2 says that we're given this arithmetic sequence 8, 11, 14, 17, and we want to determine the sum of the first 20 terms. So again, first 20 terms, we're looking for the sum. Now I don't know what a of 20 is, right? A of 20 is a question mark. It only gives me the first 4 terms. So I need to use the first type of the sum equation. So that's going to be s sub n equals n over 2, 2 times a sub 1 plus n minus 1 multiplied by d. Okay, so thinking about what variables do I know? My first term is 8. My common difference, I'm going to take the second term and subtract it from the first term. That's going to be 11 minus 8. My common difference is 3. I know my n value is 20 because that's first 20 terms. And what I'm looking for is s of 20. So I have 20 terms divided by 2. 2 times my first term is 8 plus 20 minus 1 times my common difference of 3. Okay. And then I'm going to go ahead and evaluate that. I end up with 10 times 16 plus 57. S of 20 equals 730. Okay. Try student example number 2 on your own.